all, and welcome to the first Intro to Calculus video lecture of the school year. I'm going to cover a couple things at the beginning of the video. Granted, I think all of you had me last year. It's going to function pretty similarly, but I'm going over all these details at the beginning because I think that it's helpful for everyone to be reminded. So the videos are going to look basically like this. I've learned a couple of tricks just making these first couple. I've made it one for intro and one for pre-calculus so far. I've learned from those. So they're going to change a little bit as we go forward, but not too much. One thing that you'll see is you'll always see the objective at the top. Just like last year, you're going to be able to either take notes on your own notebook or loose leaf. There'll also be the guided notes available to you if you want to print those out and take notes along with. Then you're going to see the homework. This is going to be from Chapter 1, Section 1. You'll have the recommended practice. I don't expect everyone to do every single problem. Be working for your 30 to 35 minutes total on math. There's going to be some days where maybe you're working 20 and then the next day you're working 40. I can't promise it's going to be perfectly 30 every single day because some topics are going to be harder than others. So just enjoy the days that you only have 15 minutes of math, knowing that maybe sometime in the future you'll have 45. I'm going to try to keep weeks at least balanced as best I can, but that's just sort of the possibility. You have your practice problems that are odd. The answers are in the back of the book, just like in pre-calc. And then there's the presentation problem, which is the problem you're going to attach to the assignment for me to grade. I will give feedback for these problems as you go. And they're due on Friday. So if you're not sure about the presentation problem and you post it, make sure you're checking your email for any comments that I might have left on that assignment when I start going through them on Friday. When you check the homework problems in the back of the book, just like last year, if you're saying, oh, I'm really stuck on 15, I have no idea how to do it, there's a form in this assignment where you can go and pick 15 or 23 or some combination of whichever problems you're stuck on. That will help you figure out those issues. And if a bunch of students ask for a problem to be gone over, I will make a video or I'll make a written explanation of how to do that problem. So once you've got yourself all ready for notes, you've got your writing utensils, you've got either loose leaf or a printout, you'll be able to get started here. So we're going to start with today, interpret various representations of functions. So we've got a graph of a function here. Given the graph on the left, answer the following questions. So the first is, how do we know it's a function? Now, what a lot of you are thinking, and which is absolutely accurate, is you'd say, oh, it passes the vertical line test. Now, one thing I want to do is make sure that we have a stricter definition of the vertical line test than maybe we had before. Because what the vertical line test does is it says that for every x in the domain, there exists exactly one f of x. So this is what it specifically means, right? There's not going to be 0 f of x for every x, and there's definitely not going to be multiple. This is the very specific definition of the vertical line test that is used for functions across the board. So here we have a function. First thing with the graph, it says find f of -1. So this means that x is equal to -1. So with the graph, that means our goal is to find the y value since we know the x value. And if we look here on the graph, -1 is right here on the x. So the point on the graph there would be right here. And then the y value is 0. So you can just write y or f of -1 equals 0. The other type question, very similar, approximate where f of x is equal to -2. So if I'm again looking over here on the graph, if it says that f of x is equal to -2, f of x, remember, is the same as y. So y is equal to -2, and our goal is to find x. Looking at the graph, the y-axis, -2 is here, and we have one point where that's true, and it's between 1 and 2. So you could say x is equal to, and looking at that, it's about 1.5. If you want to write 1.4 or 1.6, I wouldn't count that as incorrect. All right, so we use this word here before domain, and next thing we're going to do is state the domain and range of f of x. So let's make sure we have those defined. Remember, domain are all the x values and range are all the y values. So then the range is the set of all the f of x's that line up with the vertical line test. So when we're asked to find the domain and range of f of x, I'm going to be switching back and forth here with the graph a little bit. The domain here is the x values, which we can see the x values go from -3 to 3. And we will write that like this. We could just write -3 to 3, but that's not the mathematically perfect way to do it. So the domain, we're going to write it in interval notation, if you remember. So interval notation means that you've got two numbers, your minimum, and the maximum in the interval. And then you choose open or closed boundaries depending on if that final number is included or excluded from the domain and range. So if you remember, with open boundaries, that means that the value is not included, and the circle might look like this, and we use parentheses. And with closed, that means that that endpoint is filled in, and we use brackets. Now, you also might remember that if, for example, there is no endpoint, if there's just an arrow because it goes towards infinity, that'll also be always open. So in this case, if we look at our graph here, we're going from closed intervals, not -3 to 2, I apologize. I'm sure there's some of you already panicking. Sorry, to +2. So -3 to 2, and we're going to go back here, and we're going to say the domain is closed because those are filled in points. -3 is the lowest x value, and 2 is the highest x value, like so. The range is the same basic principle, but it's the y values. So if I'm looking at my y values here, my maximum y value is 3, my minimum y value is -3. And so then, again, minimum is -3, maximum is +3. You can write it like that. The last interval it asks where it's increasing. Something is increasing when the graph is going up or that it has a positive slope. So if something is going like this on some interval. So if I'm looking here, this has a negative slope, and then we have a section that has a positive and then goes back down. So the increasing section goes from here to here, and then it turns back down. Now you'll notice that at the ends we have these flat places. This is where it's not increasing or decreasing. This is when the slope is equal to 0. So that means that we don't include those endpoints, meaning we're talking about open circles. In that interval, if it doesn't specify, this will always be for x values. So looking back at the graph, we'll notice that we are talking about an x value that's pretty close to -2. It's in between -1 and -2. I'm going to approximate it as -1.8, and then as we said before, we're going to have that open boundary. And then the other endpoint is at the x value of 0, and that feels pretty on for me, so I'm going to say 0 here as the end of our interval with another open boundary because we don't count those flat extreme values. All right, number 2, so that's looking at a graph. Here you've got an information, it might ask you to sketch a graph. Sketch a rough graph of the number of hours of daylight as a function of the time of year in Minnesota and along the equator. So 2 separate lines or curves in this case. First thing I'm going to do is draw my axes and label them. The way it's written, we can tell which one should be the x and which one should be the y. So when it says the number of hours of daylight as a function, that means that this is going to be the as a function is the f of x, which means it's the y-axis. And then the other variable, time of year, that means that this is going to be the x-axis. So I'm going to label those quickly. So I've got them numbered and labeled. We've got our months of the year, January through December, or 1 through 12, and then hours of the day. Now, if you would like to use Google and get really specific answers, I am never going to discourage that. That's what I did in this problem, and I learned that in Minnesota, the shortest amount of daylight that we ever have is approximately 9 hours. So I'm going to put that halfway between 6 and 12, right around January, right at the solstice. And then it gradually increases until we're at 12, right around at the end of March, because that is the equinox. Our summer solstice is right at the end of June, and that's going to be about halfway between 18 and 12. We get about 16. Back down for the fall equinox, and then we'll lower it again. So you'll see we have a sort of periodic curve, and the farther towards the poles you get, that's more extreme. So this is Minnesota. And then, as you might have guessed, at the equator, it stays pretty the same. Like if you want to draw it changing, you can, but it's going to be pretty consistent like that. So some of these might require a little bit of Googling for you. That'll be just fine. I know this video is a little bit long. I want to keep them about 10 minutes, but we had to go over a couple things at the beginning that'll hopefully become second nature pretty soon. So tackle the homework now, check those answers in the back of the book, and then post the presentation problem to Google Classroom. If you have any questions, leave them in the comments, or if we haven't had our one-on-one meeting yet, you can ask me it then. Talk to you later.